So we're flying at around like 100,000 feet with Mach 5, which is going to be like a mile a second. So that's just crazy to think that we're traveling that fast, where each second we're going across what would take like an Olympic sprinter, 4 minutes to get around a track to complete? So Hermeus is a company that's looking to radically accelerate air travel. We've been developing hypersonic vehicles for about the past 4 years, looking to come up with these concepts that can fly between New York and London in around 90 minutes. So the enabling technology for us is going to be our engine. Our turbine-based combined cycle is going to be what takes us from takeoff through climb and up to cruise. By being able to leverage both a turbojet engine and a ramjet engine, we're able to really get up to those high Mach numbers, like Mach 5 or so, to be able to actually cruise at these high speed conditions that gets us between point to point. For the other technologies, we also have what we would consider more of like a wave rider style configuration. We want to be leveraging the latest and greatest in aerodynamic technology and trying to extend that technology down to the point where we're able to take off and land effectively and not just be a point design solution. And finally, we've got our inlet, which is going to enable us to provide high quality airflow to our engine. That's really what's going to drive a lot of the performance and thrust that we're able to get out of the engine itself. So being able to ensure that we've got a good design and high quality flow is really critical to what we do. So really the big challenges that come along with these technologies is really finding ways to make them all come together. So starting with the engine, the inlet, the aerodynamics, all these things are in and of themselves difficult challenges to solve. And we have a lot of really great solutions that we're able to go after to analyze them and understand what's going on. Where it gets complicated is when we start to have these conflicting requirements, whether it's from the engine and the OML, ensuring that we have enough packaging space around the things that go inside the aircraft, or whether it's the amount of heat that this engine is going to produce that's potentially going to cook everything inside this vehicle. So being able to integrate that with the amount of work that we're doing on the aerodynamics side and the inlet side to ensure that we've got a really good solution is where the challenges really come into play. Integrating these things is definitely the hardest thing we have to do. So Cadence really has helped us to move quickly in design. We're able to really get to a high fidelity answer with a lot of confidence in what we're seeing at a much more rapid rate than what we were previously able to do. Cadence CFD really came in and showed us that we can design these air intakes and understand what's going on with the high fidelity solutions that we're receiving at a much more rapid rate than what we were previously able to do. So Cadence Pointwise, we've really been able to leverage the Flashpoint auto meshing solution to generate these high quality surface and volume meshes at a much more rapid rate than what we would previously been able to do. It really enables us to take these best practices that we've learned using Pointwise over the years and integrate those into solutions that are way less hands-on for our engineers. And it gives us a really high-quality result that we're super thrilled with. So we're really excited to be working with the Cadence team and are thrilled to have them on board and getting Mach 5 to a reality. These vehicles wouldn't happen without these high-fidelity solutions that we're able to get, and it really helps us to have the support of the Cadence team.